What are you doing, Erika?
I'm trying to understand what is this. I don't know how to name it.
What is that?
And the hydrocarbons, I think. Yes.
What is your problem?
I don't know how to name it.
Don't worry, we can show you how to name it. So let's name them.
Hello, Miss. My name is Martin Castillo, and in this time we are going to talk about how to name hydrocarbons and its origin and that stuff from hydrocarbons, obviously. The first concept, the first name important is UPAC. UPAC is an organization created in 1919 by scientists and academicians that help us to know what we are using in a practice, in an experiment, or something like that. It means International Union of Pure and Applied Chemistry. This means that this organization sets all the naming rules and the symbols that now we know, and also some characteristics of different compounds and substances. But this organization that is not affiliated with any government tells us that there exist different types of hydrocarbons. The first is alkanes, the next are alkenes, after we have alkynes, and finally additives. Each one have its determined characteristics, but we are going to give a representative examples. For example, the first one is from alkanes, and we have CH4, called methane. The next is from alkenes, and is the H2C double bond because it's its main characteristic from alkenes. The next CH2 also. This is called ethene. From alkenes, we have the HC and the triple bond, very important to recognize the alkynes, and then the CH. This is called ethene. This is important because we need to recognize when we are using determined hydrocarbon to know how to use it, or maybe for what will be useful, or different things that can vary in an experiment that involves hydrocarbons. But these rules are important, and we are going to view in a moment. Thank you.
In order to know how to name the alkenes, alkynes, alkanes, we have to know the prefix. And here we have the prefix from the 1 to the 10. The prefix for 1 is met, for 2 is et, for 3 is prop, for 4 is but, for 5 is pent, for 6 is x, for 7 is et, for 8 is oct, for 9 is non, and for 10 is dec. But why these numbers? The 4 is before the branch chain. We number from 1 to 8 to the right to left. 1. We have 1, 2, 3, and 4. And number 4 we have the 10. That's why the numbers 4 and the 10 are combined. But 3 and 5, why two numbers? Because we have two methyls and their location are at 3 and 5. We put a comma, 3, comma 5. But D is a prefix that we use when we have, in this case, D is for 2. We have two methyls in this case. And oct is because we have, as we said, 8 carbons. 1, 2, 3, 4, 5, 6, 7, and 8. Well, we have the alkanes, but there is cyclic alkane. But how can we name it? Well, first of all, the branch chain is always the ring. The ring is a figure. Second, for 1 to the 10, like this case, no numbers are required. Just this. The rules for name alkenes are basically the same as the rules for name alkanes, but with some additional rules. One of them is that the parent chain must include the double bond. That means that my parent chain will be this.
Now I am going to explain you how to name alkynes. This is exactly the same as the alkenes, but with the difference that we are using the suffix "-ine" instead of the suffix "-in". Now I am going to explain you how to name these hydrocarbons with following the steps. First, we need to identify the parent chain which has the triple bond, which is this. And then number the carbons from the ending closest to the bond. I have numbered from left to right, but it can be right to left because the bond is in the middle. Now indicate the location of the bond and change the ending for a wine if we have the triple bond. So I'm going to start with naming this hydrocarbon. First, we need to identify the branches of it, which are located in the 3 and the 6. Now we are going to put this, and because we have two methyls, we will write the methyl. Now we need to identify where the bonds are located. We have that it is located on the 1, 2, 3, 4 position of the bonds. So we'll put the number 4 and put this again. And now we will write octane because it has 8 carbons on the parent chain and it has a triple bond.
Okay, to name the aromatic compounds, we need to first contain the aromatic compounds contain a benzene. That is, to make more easily, we have to do this type of benzene. Also, the aromatic compounds contain 6 sensor carbon ring with 3 alternate double bonds in resonance. To name aromatic compounds with one substituent, first we need to identify the compound that we have. Here is ethyl, and then we need to add the name benzene.
Having rules to name hydrocarbons is important because there are so many hydrocarbons, and having rules to name them makes easier the comprehension of which hydrocarbon we are referring.
This classification of hydrocarbons serves as an aid in assessing structural features and properties, but does require that a particular substance be acting to a single class.
In this stage, the knowledge acquired about the rules to name the different compounds have a biggest importance in our learning, because basically in chemistry are the principal part in the branch of organic chemistry. Also to give a name in order to identify them easier.
In my opinion, I think that naming hydrocarbons is very important because that way we can classify them and avoid accidents when we are working with them. In addition, I think that naming them helps us to better know their characteristics and use them in a more effective way.
I think that hydrocarbons are important for make a corrective procedure in a practice or experiment, and the UPAC help us to know how to use them, name them, and identify them also.
We can conclude that the hydrocarbons are so important because they are the building blocks of everything that defines our society. They are actually too important to born, even though we mainly use them as fuel. Homework medicine, material science, just to name a few, are synthetic products of hydrocarbons.